So if you were fine doing the slides, the flips, and the turns, and the blowing things up yesterday, you'll be just fine today. You just might get a little bit frustrated because there's so many dots to plot. All right? So just kind of take a deep breath and plot your dots. And the last section of the chapter we'll be testing on Friday. So on this sheet of paper, this one's our notes. Again, I'm keeping you out of our note packet. We have a few little things we'll need to clean up tomorrow because I've kept you out of the note packet. There's one or two just tiny little nuggets of information I have to give you tomorrow. But what you're going to be doing today is called a composition of transformations. Some books call them sequences. Okay? Or you can just think you do one followed by another. Luckily, we're not going to have you do more than two, because two is plenty. Because you have to plot lots and lots of dots. But the first thing is that a composition of two isometries, so we need to remember what that word means. An isometry preserves both the size and the shape. It keeps things congruent. If your composition of two isometries does not yield an isometry, which means if you have a reflection followed by a turn, your figure should be the exact same size and shape. If you do a reflection followed by a slide, they should be the exact same size and shape. Last hour that was nice for me walking around because somebody's rectangle turned into a rhombus. I was like, you must have plotted your dots wrong. So that's easy for me to kind of walk around and check. The only thing that's going to cause your a change in what you're looking at is if one of them is a dilation, because then things will shrink or blow up. But your rectangle should never turn into a triangle. Your right triangle should never turn into a scalene triangle. They're always the same shape. The dilation will change size. So that was kind of a nice way for me. Kids saying, did I do it right last hour? I'd look at it, and if anything of the shape was off, I'd say your dots were plotted. And I saw some of that because I plotted one of them wrong, and I'm the teacher. And I looked at mine, and I'm like, all of a sudden my triangle had a longer side than it used to. So I had to go check all my dots. Does that make sense? So keep track. Everything should be exactly the same shape. And as long as you don't have a dilation, they're going to be the exact same size as well. So what you're going to be doing is a sequence of stuff you already know how to do. So I'm going to give you how I want you to do it on your homework and on your notes. We are all going to plot the original figure on the graph. We're going to label it, and we're going to shade it with one of our colors. So that when Miss Elle and I walk around, we can look, because we're going to be checking your number 2. And we want to know where your original was and where your final one ends up. Okay? So we're going to go 3 to the left. And by the way, this is an 8x8 grid on all these. And on your homework as well, so that'll kind of help you. Like if you know you have to go out to 7, just leave one box up. But this is 3 to the left and 7 up, so I don't even really need to count since I know it's 8x8. Make sure you label that with an X. So we're going to go put our original on our graph. All right, and then we're going to go to Y, which is 2 to the left and 1 up, and we're going to label it. Make sure you label them so we can tell you which point is off or where you're out of whack. And then we're going to go 5 to the left, and we'll go 2 up, and we'll label that Z. We're going to carefully draw it, and we're going to shade it with one of our colors. I chose yellow as my originals all hour last hour, so I'm going to stick with that. Whatever you do, just be consistent throughout the hour. Like I see Michaela choosing a green highlighter, then her originals on all of them should be green. Okay? So and maybe you're going to make your original in pencil. It doesn't really matter, but that's my original one sitting there. You have been used to doing one thing to it. You've either been sliding it, flipping it, turning it, or blowing it up / shrinking it. For this one, you're told to do 2 things. A, you're first going to reflect it over the x-axis. Well, the first time I do something, it's called x prime, y prime, z prime. Does that make sense? So I'm going to hop on here, and I'm going to find my rule for reflecting over the x-axis. Should be on your note card. That's why I said have your note cards out in case your rules, my guess is you don't have them memorized. I don't. So when you flip something over the x-axis, if you want to do it mathematically, which is last hour what they chose to do, because they just got sick of counting boxes. So if you want to do it mathematically, what's your rule on your note card? Avery, for flipping over the x-axis? It says it goes to what?
X negative.
X opposite of y. Just go grab all those x coordinates and keep them. So I just go ahead and keep them at the same x, and then I'll take the opposite of all my y's. -7, -1, -2. I'm going to have you go plot that. You won't shade it in. It's going to be our stepping stone. Like, it's not our original and it's not our answer. It's just going to flip this guy over the x-axis, and make sure you label them. So I'll go to -3, -7. Remember, it's an 8x8 grid, so let that kind of help you plot. So there's my first dot. I'm calling it x prime, or my new x. Then I'm going to go 2 to the left and 1 down. I'm going to call it my new y. And then for my z, I'm just going to go put it at -5, -2. You're going to connect it. I'm going to wait for you to catch up. It should be the same size. It should be the same shape. It should look like it flipped over the x-axis. If yours doesn't, you did something wrong. Don't shade that one in. And that's just sort of the helping guide. All right, so if you could kind of put your hand up when you've got that graphed. I'm going to do the first one slow. Okay, perfect. Now you're going to go and do your next transformation. You're going to look and you're going to go, oh, it's a translation, which means this is going to just be sliding on the grid. Okay? You have to make sure you know what this rule tells you. Your next one should look like it slid 9 in which direction? To the right and 2 up. But it's easier for some kids, instead of going 1, 2, 3, 4, 5, just redo your dots down here. So here's my double prime. You could label it if you want, but I would just go take all these x coordinates and mathematically move them to the right. Because going like this on my grid makes me crappy. Like going 1, 2, 3, 4, 5, 6. So just go add 9 to all these x's. Make sure I do my arithmetic right. I didn't last hour in one of them, and they didn't tell me till I was like all done, and I had a dented in triangle. Okay, so those are my new x's. I just added 9 to all of them. And my new y's, I'm going to add 2 to all of them carefully. 1 and then 0. Okay, so I'm sitting right there. With another one I need to plot. Make your origin nice and big so that you know when you're plotting these dots, you're plotting them from the origin. So my new point is going to be 6 to the right. 1, 2, 3, 4, 5, 6. Sorry. I made my dot really big. 1, 2, 3, 4, 5, 6. And then it's going to be 5 down. And I'm going to label that x double. And then 7 to the right and 1 up, I am going to label y double. And then 4, 0, 1, 2, 3, 4, 0. I'm going to label it z double. I'm going to connect it. The size and shape should not change. It should look like it flipped and then it slid, and it does. So if all looks good and my triangle didn't turn into something weird, I'm going to grab what I'm going to call my answer color. Last hour I used pink, and I'm going to shade it in. So every problem should have 3 shapes on it. The original shaded, the first image unshaded, and the final answer shaded. And on your whole assignment, I would stick with that. So mine, I'm going to go yellow, unshaded, purple. You kind of have the process down for how, yep, Mark?
You know it. You know another part.
They're all up here. Yep, and you can choose markers or you can choose highlighters. All right, so we're going to pick up the pace a little bit here, number 2. I'm not doing all these examples. You'd go crazy. But I'm trying to find all the different nuances, and I think we figured that out last hour. I chose number 2 because this says translation, which is a slide, but we skipped in our last chapter, we skipped what vectors were. So this really just means slide it to x plus 7, y minus 5. So it's just different notation for doing a slide. So just know every time it says the vector, if it says 4, 3, you're going to go 4 to the right, 3 up. If it says the vector -1, 2, you're going to go 1 to the left, 2 up. It's the same. So that says translation, so I knew it was a slide. And this just means up 7, down 5. Are you okay with that? I also chose number 2 because this rule is not on your note card, so we're going to deal with it. Whenever you do a translation followed by a reflection, it gets a special name in geometry. It's called a glide reflection. I don't know why they picked that one out and give it a special name, but it is. It is also an isometry. So if you were asked, is a glide reflection an isometry, you'd say yes, but make sure you know why. It's because the size and the shape, when I slide and then flip, is not going to change. Okay? What did I say? The only thing is going to cause it to have a change in appearance is if one of those transformations is a dilation. Yeah, and that's not what's happening here. So whatever my original triangle looks like, my last one's going to look just like it. Its orientation is just going to change. Okay, so let's go on here. And again, we're going to start by plotting carefully our original. It's an 8x8 grid, so you should know you just need to go to the one, like that helps you if you know the shape of the grid. And then we label those so that we don't get mixed up. And then 1 to the left and 3 up. We'll label it. And then it looks like 6 to the left, here, and 6 up, which would be here, and I'm going to label it. It's making a right triangle. My final answer should be a right triangle, right? And it should be the exact same size as this right triangle, but it's going to end up someplace else, okay? So my first thing is I am supposed to slide it. I told you this means 7 to the right and 5 down. Do you want to move it? Ava, do you like to move your pencil 7 to the right and 5 down? Or do you like to do the math and then plot it? Okay, and you can choose. I don't care how you get the middle one. As long as your final one's in the right spot. I like to do the math too because I'm a math person. So I like to just go up here and add 7 to all my x's, which is going to put them at 6, 6, and 1. It's just so easy, right? Just to do the arithmetic of it. And then I'm going to subtract 5 from all my y's, which will put it at 1, -2, 1. Did I do my arithmetic okay? This is the one I screwed up last hour, and it made something that wasn't a right triangle. So you'll know if you messed up, right? So let's go over there, and we're going to plot 6. And again, you always go from the origin. If you're going to do the arithmetic first, I'll go 6 to the right, 1 up, and that is my new G. So I'm going to label it G prime. I'm going to go 6 to the right and 2 down, and that's my new H. And then I'm going to go to 1, 1, and that's my new I. I'm going to go like this, and I forgot to shade the original, so I'm going to go do that. My shading is in yellow for my original. This looks great. Actually, did I do 5 on which one? G. Yeah, I did. Do you see how mine shrunk a little bit? And I said, actually, she's right. I only went out to 5 instead of out to 6. I can fix that pretty easily. But even I for some reason, this number 2, it's not liking me today.
So the second one doesn't get shaded?
Nope. I mean, if you want to go with a third color, but just the second one's just sort of a means to get to the final answer. So, next thing I'm going to do is I'm going to go look at letter B, and I'm going to actually draw mine a little bit nicer now because I have to use the graph on letter B. So I'm going to make sure that this guy's nice and it's not shaded. It says I'm supposed to flip it or reflect it over y equals -3. There's no rule for that on your note card, but we did see y equals makes a horizontal line, correct? So what you're going to do is you're going to go and draw that line in. Y equals -3 is 3 down on the y-axis, and you're just going to go draw your line that you're supposed to flip over. And then what did we say we do for those? You walk to it and you walk away. And then we'll write our G double prime right here. Okay, so I'm going to walk to that line of flippage. 1, 2, 3, 4 to get there. When I fold my paper over it, it'll be 4 away, over here, It's still 6 to the right, but it's now 7 down. That's my new G. My new H is 1 away from the reflection line. So I walk to it like Ava said, and 1 away. It is still 6 to the right. Notice those x coordinates stay the same, so there is sort of a pattern. Anyway, I am still 6 to the right, but now I'm how far down? 4, right? Yep, I'm 1 below the line of reflection. And last up, my 1, 1, it looks like I have to go 1, 2, 3, 4 to get there. 1, 2, 3, 4 to get away. It's my new I. It looks really good because it's still a right triangle, and it looks really, really like it got slid and then flipped. It looks great. So once I realized that I've done a really good job, I grabbed my final highlighter and I shaded it. I would like to say I made a mistake on purpose when I accidentally went to 5, but I didn't. So that's a good rule for you guys. If your things don't look the same size and shape, unless it's a dilation, you did plot something wrong. All right, how are we doing so far? We good? We're not going to do all of these. Number 3, we are going to do this one because we haven't done a rotation. So what did I say when they put the slides in this notation that it means? We skipped vectors in our chapter 9, but if I'm supposed to slide it and I've got a positive 4 and a positive 10, what does that mean I'm going to do? Add 4 and then what? Add 10. Yeah, so if you want to rewrite that in our notation, vectors are actually used for this more in higher levels of math. Like in my calculus class, we use a lot of vectors. We'll use them in science, but for geometry, we've been keeping those slides just as x plus and y plus. So first thing we do is we go graph that rhombus. And again, we start at the origin when we're plotting our dots. So 1 to the left, 3 down. Make sure you label it. If it doesn't make a rhombus, we did it wrong. So kind of let those things guide you. I'm going to go 3 to the right and 4 down. That's my Q. I'm going to go 4 to the right and 8 down, and it's an 8 by 8 grid, so I go all the way to the bottom there. And then 0, -7. That's my S. Mine looks very much like a rhombus, because what does a rhombus have? Remember from last chapter, or 2 chapters ago? What does a rhombus have? That makes 4 congruent sides, right? I'm going to shade that in because it's looking good and it looks like a rhombus. If it didn't, I would go check my plotting. So there's my original. Am I going too fast, guys? No? All right. So for letter A, I'm going to take that rhombus and I'm going to slide it. You guys seem to like doing that mathematically, so I'm going to add 4 to all those x coordinates. It'll go, P will go to 3, and then adding 4, adding 4, adding 4. That just will slide it mathematically. 4 to the right. I'm going to add 10 to all those y's. Be a +7, +6. And then I'm going to ask you guys if I made any arithmetic mistakes, because I don't want to plot 4 dots and have it not be a rhombus. I did make a mistake, Alex? I didn't? Okay, good. All right, so you get, if you were in my calculus class, they would tell you I never make a high-level math skill mistake. I just don't. But arithmetic, they laugh at me sometimes. Like I'll do 3 times 2 is 5, like right in the middle of a super complex physics problem. So watch my arithmetic. So we're going to go plot our new guy from the origin since we did the math. We're not going from here. We're always plotting our dots from the origin. So we're going to go 3 to the left and 7 up, and we're going to label that new P. And then 7, and then 6, and we're going to label that new Q. So it's just sort of sit back and relax today and plot dots carefully. Right, Miss L? And I say plot dots carefully because I've been sloppy twice today, once last hour. And I'd like to say I did it on purpose to show you, but I didn't. I was purely being sloppy. don't shade that one in, but it looks good. So I wouldn't even double check anything. It's the same size, it's the same shape. It looked like it went to the right 4 and up 10. It looks awesome. So I'll let you guys get that one on there. Then down here, we're going to mathematically turn it 90 degrees against the clock. So look at everybody look up here for a second. Everybody look up. So there's going to be a rhombus somewhere over here, right? Turned 90 degrees against the clock. But I forgot the rule for that. Maybe you did as well. So you're going to go to your note card and tell me what the rule is for 90 counterclockwise. Yeah, Ava? Can somebody back her on that so that I don't have,
Yeah.
Okay, I'd hate to do that and have her accidentally grab the wrong rule. All right, so let's go mathematically get our final image by doing the opposite of y, keeping the x, by doing the opposite, and I'm saying it every time. And I'm not saying negative, I'm saying opposite. Opposite of y, keep the x. Opposite of y, keep the x. These will be labeled P double, because it's after my second transformation. If I had a third, you would label them P triple, Q triple. Andrew, now what do? Plot 4 more dots. Right? So a lot of dot plots. Then if it doesn't make a rhombus, and if that rhombus doesn't end up over here somewhere, we did it wrong. So let's go plot 7 to the left, 3 up, new P. Boom. 6 to the left, 7 up. It helps knowing it's an 8 by 8 grid. It helps the counting. Do you know what I mean by that? Like it's helpful to know it's 8 by 8. So that if it says 7, I know I don't have to actually count. 2 to the left and 8 up is my new R. And 3 to the left and 4 up is new S. Connect, 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 connect. I'm feeling really good about it for 2 reasons. Itsy bitsy izzy bee, give me one reason why you think I'm feeling really good about what I just did on that one. It looks like a turn. It looks like a 90-degree counterclockwise turn. Watch if I connect these. I've got 90 degrees against the clock. So it looks great, correct? And it's the same size and the same shape. I just actually drew this line got drawn a little funky. So once I'm pretty sure it looks good, I am going to ask you a favor. If yours doesn't look good for some reason, check your own dots before you ask Miss Eller or myself what's wrong with it, because it's a pain to check all the dots. All right? So last one up. We're going to go to number 8. And we might not finish it. I just wanted to make sure I picked one. As long as we're getting it, we don't need to do all of these. But I wanted to pick one that I wanted you to flip over an axis, a horizontal, a vertical, do a dilation, a rotation, and all of this. So this one I'm picking because we haven't flipped that way yet today. And we also haven't done a dilation yet today. Here's what I want you to do though. Cross this off. We are only dilating about the origin. So go ahead and change that. So when I get notes from other places, sometimes we have to tweak them a teeny bit. All right. Let's all go plot the original. And then look up here when yours is done being plotted, just to make sure it looks good. Double check mine while I'm... Yeah, it's a skinny little thing down there. That's why I said I'm going to double check mine, because it was very tiny. Just to keep the vocabulary going, that's called the pre-image. It's before the move. All right, our first thing is a reflection over x equals -2. So if Alyssa goes to her note card and says, Lerud, there's no rule for that, I'd say that's because there isn't one really. What do? TT? For a reflection in the line x equals -2. Thank you for saying vertical. Somebody last hour said draw a straight line. I'm like, all lines are straight. So yes, a vertical line, she said, through x, she said it perfectly, through x equals -2. Excellent. Got a nice one right here. There's no rule for this, right? What am I going to do with my pencil, Brody? To get my new P, and my new R, so that when I'm done, I can blow them up. How do I flip it over that thing?
Just gonna walk and then walk.
Yeah, that's how I do it. I like to just walk to it, and then I land on it. So I just folded my paper, so it's going to land 2 over here. I'm going to label it new P, and then I have to go put its coordinates right here. So though it's kind of a reverse. Instead of coordinates plot, you have to plot and then do the coordinates. And then Ronan for the next one, for Q, I just have to go 1, 2, 3, 4 steps to get to the fold. So 1, 2, 3, 4 to move away from the fold, call it new Q. And remember, the coordinates go from the origin. So this is 2 to the right and 3 down. I'm going to write 2, -3. So for these, you have to physically flip it with your pencil and then write the coordinates down. My new R has to be 3 to the right. My new R, what's that? Put it at 1, -5. Yeah, 1, -5. I got to make sure I write them all down correctly for the next thing I'm going to do. I'm draw a nice straight line here. All lines are straight. I feel really good about it. It didn't change size or shape, and it certainly looked like it flipped over that blue line, so I'm ready. I'm not going to shade it in. And if I didn't feel good about it, I'd go fix it, right? Do you know why, Maddie, I feel good about it? I feel good about that. Why? It looks like it did what it's supposed to do without changing size or shape. This says dilation, so if you were asked on a test if this transformation or composition is an isometry, you'd say no, because with a scale factor of 3, I'm now going to take and triple the size of it. And from yesterday, we said that to do the dilations, do you add, subtract, multiply, or divide? You multiply by the scale factor. So I'm quickly going to go in here, and I'm going to multiply every number by 3. So I'm going to say that's not going to move. 6, -9, and then 3, -15. And because that one goes off the grid, because it gets so big, you don't need to go plot it. There's one on your homework where it says 1/3, and some kid said, what do I do with the 1/3? I said the same thing you do if it was 3. You multiply by 1/3. If you don't like that, I told her she's a third of my age. She could take my age and divide it by 3, right? So if you don't like multiplying by 1/3, that's the same as dividing everything by 3. So that last hour, some of them didn't like the 1/3. I said, well, you're just dividing everything by 3. And they are actually all multiples of 3. So it's super easy. All right. So for your homework, we are going to go in and tweak ones that need tweaking. So that one's good. Just remember what this means. Okay, when it says, sometimes this worksheet mixes the translations. So remember, this means it's going to x -5, y -1, and number 3. Here's that 1/3 scale factor that bugged last hour. So if you don't like multiplying by 1/3, what did I say you can choose to do instead? What did I say you can do instead? Divide by 3. Yeah, if you're not a fan of multiplying by a fraction. There was one dilation. This one says centered at the origin. There's one that's not, so we're going to make
Hold
it.
up, Mr. I don't even know where this sheet is.
Oh, I didn't pass it out. Too funny. All right. Thank you, Sawyer, for. Here you go. 1, 2, 3, 4. If you're working well on it, and that means 100% of you, we'll cross off number 6. You already grabbed them. If you're not, we'll just put it there. All right. So we're going to do this exactly as we did the homework. I'll go back and give you my directions again. Come and grab one. All right. So on the first page, the only thing I said to beware of is this number 3. you might want to get it out of the slide, get it out of the vector notation. So I'll make it x minus 5, y minus 1. That's the first thing I told you to tweak. The next thing you're going to want to tweak is for A, we're going to have it go about the origin, which it says, so that's fine. That's fine as well. So like for A, that's fine. I've told you enough about that. Our dilation right here, we're going to go about the center, because that's what we've always been doing. So this worksheet was taken from a little bit more advanced book than what we use. So it's got a little bit different, but otherwise it should be good. You might be skipping number 6 depending on how well you work. We're going to do 1 together, just one last one, and then you're going to do 2, and when you're done, you're going to have Mrs. L or I check it.
What are you doing, question 3 again?
I'll tell you once we get there. All right, so let's go take a look at this guy. We're going to plot some dots really quick. It better look like a rectangle because it says it's a rectangle. So you guys go plot your dots and label them. When you're confident that you did it right, which I am, mine looks very much like a rectangle, I am going to go like that. If yours doesn't look like a rectangle, go check your dots. Once that's done, you're going to go do the first rule. It is written in the notation you're used to, so you don't need to rewrite it. I'm going to add 6 to all my x's, or you can physically move your pencil 6 to the right and then write the coordinates down. You guys have been wanting to do the math first whenever I've asked any of you, so I'm going to. Miss L, what do? Do you move and then write the coordinates down, or do you use the math and then plot it out? You do too? Okay. I didn't know how the other teachers teach it. Do they do it the same way? I don't know. I like math. I like to just go up here and add 6 to all those x's because it just goes so fast. Then I'm going to subtract 8 from all those x's. I'm going to double check them because if I did it wrong, it's not going to make a rectangle. I'm just going to double check. 6, 6, 6, 6. I'm good. Subtract 8. All right. I'm going to replot and not shade. If it doesn't make a rectangle, I'm going to go fix my dots. Mine looks super. So I'm going to go check anything. And then Carson, what does it say reflecting over the y-axis? What does it say I'm going to have to do with my coordinates? Maybe you have it memorized. Okay. So she's saying her note card says she's supposed to do the opposite of x's and all the y's. So let's go do that. Just mathematically flip it here. Opposite of x, keep the y. 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 Back over here. Mine looks Wonderful. Didn't make any mistakes. Go Lerud. So I am going to shade it and move on to number 2. We're going to come and look at your number 2. I just got to look at my key to see where it's supposed to end up. Alright. So tomorrow we'll have 5 minutes at the beginning where we need to just, because I left the note packet, there's 2 little tidbits we need to cover, and then we're going to start our meeting. They look pretty. Check this out.
I think you did it right.
If you're watching the video, we're only going to do 1 through 5. They're all working really well. So we can all cross off number 6. I just walked around and nobody was not doing it. So go ahead and cross off 6. And those of you who are absent, the assignment is 1 through 5. I have it linked on Schoology. It's not the one in the back of the blue packet. So just know that we're not in the blue packet. We haven't been since 9/2, I think.